Chemical Looping Combustion, CLC, is a technology to produce carbon-free or carbon-negative energy thanks to inherent CO2 capture. This animation gives a brief introduction to CLC. The core of the CLC process is composed of two reactors called the air reactor and the fuel reactor. Air is fed into the bottom of the air reactor to oxidize metal particles called oxygen carriers while conveying them upward in the reactor. Hence, metal oxides are transported and capture oxygen from the air. The particle-air mixture is then sent to a device called a cyclone to separate depleted air from the oxidized particles. The heavy oxidized oxygen carriers flow downwards via a loop seal into the fuel reactor, while depleted air flows into the downstream flue gas section. The oxidized particles fed into the fuel reactor are well mixed with the fuel thanks to the formation of a fluidized bed by injection of steam on the bottom of the fuel reactor. The combustion process will hence happen by transferring oxygen from the metal oxide to the fuel while producing CO2 and H2O. Therefore, there is no direct contact between air and fuel, which means that the combustion product does not contain nitrogen. The mixture of solids and gases enter a section above the fuel reactor called the carbon stripper. In the carbon stripper, reduced oxygen carrier particles are separated from the unburnt solids and sent into the air reactor for reoxidation. Oxidized particles are sent back again into the fuel reactor. Therefore, oxygen carrier particles form a loop. This is the reason why the process is called chemical looping combustion. Coming back to carbon stripper, the unburnt fuel and combustion gases are then conveyed into a cyclone. Here, unburnt solids are sent back into the fuel reactor to finalize their combustion. CO2 and H2O are separated and sent to the downstream flue gas section. Let's zoom out to see the full chain of operating units in a CLC plant. Depleted air at the outlet of the air reactor cyclone is sent to a heat exchanger to recover generated energy. Fine particles are then removed in a dedust unit. The depleted air, which is essentially nitrogen, is then sent back to the atmosphere. The operating units of the CO2 treatment system downstreams of the fuel reactor depends on the fuel quality. The flue gas first passes through a heat exchanger to recover generated combustion heat. In case of using fuels with high nitrogen content, a NOx removal unit is needed. The flue gas is then sent to a dedust unit to remove fine particles. In case of using fuels with sulfur content, a desox step may be needed. Finally, steam is separated out to the stream. The produced pure CO2 is then compressed to be sent for storage or utilization. A CLC plant can produce different products depending on the application. Depleted air can be used to produce nitrogen. Combustion energy recovered from flue gases in solid phase is transferred into a steam cycle to produce carbon-free electricity. Steam can also be directly used for industrial applications, for example in a refinery or petrochemical plant. Produced energy with CLC is free of CO2 emission. In case of using biomass as fuel, the produced energy has negative carbon content. This means that it inverses CO2 emission by indirectly capturing CO2 from atmosphere. High-purity captured CO2 is sent for storage or utilization. In addition, depending on the fuel, CLC may produce some byproducts, including water, treatment chemicals, and oxygen carrier fines.